So the name of this process again is anti-differentiation. If I have the derivative of a function and I wish to undo that derivative, the thing I am looking for is called an antiderivative. And again, they are not unique. There's lots and lots of ways we can write an antiderivative for any given function. However, we know that every antiderivative of this function is just some particular antiderivative plus a constant. So here's my two-step plan for finding a particular antiderivative. I need more information than just the derivative of the function by itself. Derivative of a function has infinitely many antiderivatives. I need only one more piece of information. I need the y-intercept of my antiderivative. That would be enough. Or any point on the curve, any coordinate that that antiderivative passes through. So step one, I'm going to look at this function, f prime of x equals 3x squared. Excuse me. What function could have 3x squared as its derivative? X cubed. Yes, the derivative of x cubed is 3x squared. I remember that. So that's one possible antiderivative. But that means that every antiderivative is going to be x cubed plus some number. I just got to figure out what that number is. Okay. So what am I going to do? My y-intercept, what coordinate does this graph hit the y-axis? X equals 0, y equals 1. So I'm going to take the formula for my antiderivative. I'm going to put in x equals 0, and I'm supposed to get 1 out of that formula, right? F of 0 is supposed to be equal to 1. 0 cubed is just 0. 0 cubed plus a constant is supposed to be 1. That means my constant's got to be 1. It's that simple. First, I find the antiderivative, just sort of this generic one. Then I'm going to solve for that constant using whatever else I have for my information. So again, you need extra stuff just beyond that derivative to find the antiderivative. Otherwise, we're just stuck saying, well, it should generically be this formula, and I don't know what C is. You need extra information to solve this kind of problem. Now, just as a refresher, here are examples of antiderivative rules. Every single derivative rule can be turned into an antiderivative rule, every single one. For right now, because we're just starting to learn about antiderivatives, we'll focus on some of the elementary ones. So in general, if I have some function whose derivative I know, the antiderivative of that function is my original function plus a constant, right? I lose constants when I take derivatives. I lose information. So antiderivatives I need to take into account and have some constant here on the end.